Well, if it takes about a day for that single electron to make it all the way around the circuit in a car, how is it even possible that a car can start almost immediately after turning the ignition? So when you get in your car, you put the key in the ignition, you turn the ignition, and within a few moments your car starts up and you're able to drive away. Yet it takes about a day for a single electron to make it all the way around the circuit in your car. How is that even possible if it takes so long for that electron to make it around? Why does your car start almost immediately? Why doesn't it start after about a day? Well, the answer is in the electric field. Well, one thing to note is it's not that single electron that's in a battery that powers your car. Rather, that's actually a misconception. What powers your car are all the electrons everywhere in the wiring in your car. Those free electrons are everywhere. The battery isn't the source of the electrons. The electrical conductor itself, the wiring itself, the components themselves, all have unbound electrons that are the source of what powers your vehicle. All the battery does is provide an electric field to give the signal to tell those electrons to begin to move from low potential to high potential. In fact, the electric field in a circuit moves at the speed of light. When an electric field is present in a circuit, it causes all of the charge carriers to move in an extremely short amount of time. So it is the large number of electrons that move that are already present everywhere in the circuit that causes the current to power your vehicle. And it's not how fast those electrons move. It's not the electron leaving the battery. It's the electrons everywhere receiving the signal at almost the same time. We can imagine it with this illustration right here. Let's say this is just a typical wire in your car. What's depicted here are the electrons and atoms and particles within the wire that the electron has collisions with. When you turn the key in your ignition, it gives the signal through the electric field for all of the electrons in the wire to begin to move. And so once that electric field is established, the electrons respond and all begin to move in response to that electric field. So it is the movement of all of the electrons in that electrical wiring in response to the electrical signal of the electric field when you turn the key to your ignition. When you turn the key to your ignition, the electrons everywhere in the circuitry of your car responds to that signal and begins to move. Because the electrons are already there, there is an electron sitting right outside your starter motor. There's electrons sitting inside your starter motor before you turn the key. And when you turn the key, establishing that electric field, those electrons in your starter motor begin to move, causing your motor to start. And the reason why it seems like it only takes a few moments is it's because the electric field moves at the speed of light. That's extremely fast, about a football field's length in 1/1,000,000 of a second.